We will discuss few gate question on computer network. So let us begin with one question which came in gate 2016. So it is given that a network has a data transmission bandwidth of 20 into 10 to the power 6 bits per second. Now this is important, 20 into 10 to the power 6 bits per second. Okay. Next, it uses CSMA CD in the MAC layer. Okay. Also given that the minimum signal propagation time, from one node to another is 40. This is also important, microsecond. Okay. And the question is the maximum size of a frame in the network is dash bytes. Okay. So there are some bits, bytes, so we have to convert this bit byte accordingly. Okay. Now to solve this problem, we have to we remember that. So I will basically write it in CSMA CD. To detect collision, we want transmission time which is equal to round trip time or RTT. Okay, means that suppose this is your some sender and this is your receiver. So it will so the signal will go from this end to this end and it will revert back, and till it revert back there should be minimum, the packet length should be such that minimum that still this end has something to send. Okay, so this is it is going from this end to this end and from again this end to this end, and till this round trip time packet is still sending some bits, some information. Otherwise, if it already exhaust sending thing, then we could not, this end could not detect whether the collision has occurred due to this packet or other thing. Okay, so we need this. So we can write in this juncture that minimum packet size or frame size, this is the frame. Okay, we have already discussed in CSMA CD in my previous lecture. So minimum frame size is equal to round trip time into the bandwidth. Okay, into the bandwidth. This is the formula, you can check in my previous lecture. What is the round trip time? From here end to this end and from this end to this end. So it is nothing but 2 into, from this end to this end, this is a propagation delay. So 2 into propagation delay. Round trip time means 2 into propagation delay. Okay, into bandwidth. So what is the propagation delay here given? See, this is the propagation delay. See, this is given that see, with propagation time from one node to another is 40 microseconds. So this is the propagation delay. So 2 into 40 micro. So for the micro I will convert it to seconds. So it is 10 to the power minus 6. Okay. Now into your bandwidth. Okay, so bandwidth is given that 20 into 10 to the power 6. So into 20 into 10 to the power 6. Okay. So 10 to the power 6, 10 to the power 6, this is comes to your 1600 bits. And if you convert, and it is said in bytes, so you have to convert in bytes, so it will be around divided by 8. So 8 means it is near, it is 8, so it is 200 bytes. So your answer will be 200 bytes. 200 bytes. So a network has a data transmission bandwidth of 10, this 20 into 10 to the power 6. So this is nothing but your bandwidth. This is your propagation delay. 40 microsecond is propagation delay because it gives from one node to another. And maximum size of the bandwidth will be this one. Okay. So I think it will be minimum. It will not be maximum. It will be minimum. Okay. So this question is I have discussed with you. So let us go for another question which also came in GATE 2016. So let us go for it. Yeah. So it is came in 2016. Okay. So it is also based on the computer network. So the question is like that. Identify the correct sequence in which the following packet are transmitted on the network by a host when a browser requests a web page from a remote server assuming that the host has just been restarted. Okay, so it is given that identify the correct sequence in which the following packets are transmitted on the network by a host when a browser requests a web page from a remote server assuming that the host has just been restarted. Okay, so the options are given. First, HTTP GET request, then DNS query, and then TCP synchronize. SYN. Second option, DNS query, HTTP GET request, TCP synchronize. Number C, DNS query, TCP synchronized, HTTP GET request, and number D, TCP synchronized, DNS query, and HTTP GET request. So now you have to understand when you are typing the URL. Okay, so when you are typing the URL in the browser, basically you are typing that, suppose HTTP, suppose you are typing some google.com. so first that is sent via DNS. Okay, so DNS send when you type the URL, DNS take that request. Okay, so it sends, DNS sends this request to DNS server. Okay, so you have to remember, if you type that URL, DNS take that that URL and send to the DNS server. Okay, DNS from there the IP address is revert back. Okay, so that the DNS server will send you the IP address. Okay, now with that IP address, using that, with the IP address using TCP and TCP handshake, we established connection. Okay, and after the established connection, we will communicate using HTTP. So what is the main fund over here? In this case, first you type the URL. DNS will take that URL and send to the DNS server, and the DNS server will send you the IP address. With that IP address, using the help of TCP, you will go to that IP address, and after that there will be a establishment connection, and after the connection is established, you will communicate through the HTTP. Okay, so first there is a DNS followed by TCP and then HTTP. So let us see what are the options. First is DNS, so this and this. So DNS followed by TCP. So this is TCP and finally HTTP. So option C is correct. Okay. So you have to understand how the connection is made. So first you type the URL, then DNS take that URL and send to the DNS server for resolution and resolving that thing. So DNS server will send you the IP address of the corresponding URL. Then TCP comes in the picture, and TCP, with the help of TCP, you connect to that particular IP address, and after connection is established, then via HTTP you will communicate with that IP address. Okay, so first DNS, then TCP, then HTTP, and since among these four options this is correct one, so C is the correct one. Okay. Okay, thank you. We will discuss another few problems on GET in our next tutorial. Okay, thank you.